Starting our new unit. Periodic table test, I know was a little wonky. If you haven't done it yet, do your best. Don't worry about it. If you have done it, you probably are pretty happy with your grade because I was very lenient with the scoring on the periodic table test. I wasn't a huge fan of a couple questions. I will do better about questions on tests in the future so that we don't run into things like that. So we got something new to do here today. We're going to start naming bonds. So everything up to this point has been talking about single atoms. We'll tell you about one atom, and you can tell me about a different atom, blah, blah, blah. But just about everything we come into contact with is not a single atom. Just about everything we come into contact with is a molecule or a compound. It's multiple atoms bonded together. So today we're going to talk about one type of that bond that's called ionic bonds. So you can see a part of the word already in that word, ionic bond. What word have we talked about that's already in the word ionic bond? Ion. You remember what an ion is?
TV channel?
It's a TV channel, but do you remember what it is in chemistry class? It was any time the atom had a positive or negative charge. How do you get a positive or negative charge?
By adding electrons or protons.
Can you add protons?
No.
So the only way to become positive or negative is?
Adding and taking away electrons.
Very good. Adding or subtracting electrons. So the only way to become an ion is to add or subtract electrons. So the big deal I made last week was about valence electrons, understanding about valence electrons. And what's our magic number for valence electrons? 8. Everybody wants 8. So let's look at an example here. We have sodium, which is in group 1. How many valence electrons?
Sodium.
Group 1?
1.
1. Everybody cool? Then we have on the flip side of that, let's go to chlorine. How many valence electrons?
7.
7. 1, 2, 3, 4, 5, 6, 7. Which one of those is happy right now?
Chlorine. No, sodium.
Why is it happy? It's got 8?
Oh, no, none of them are happy.
Yeah, neither one of them is happy.
Okay.
Sodium wants to get 8 by getting rid of an electron to go back to 8. Chlorine wants to get 8. What's up?
Chlorine has 11.
What's up? Ask me your question. What you got?
Where did you get 7?
Count across the top, skip the middle. Valence electrons. Group 1, 1. Group 2, 2. Skip the middle. Group 13, 3. Group 14, 4. Group 15, 5. 16, 6. 17, 7.
6. Did you say
And group 18 would have 8.
Here you go. Has the middle of the periodic table always been really weird?
Well, yeah, that's what I call transition modes. You go back. You ready, Matthew? You with me? Cool?
Yeah. I like to think of it like 1, 2, and then I say 3, 4, 5, 6, 7, 8, 13, 14, 15, 16, 17.
Right.
Yeah.
I had on the handout he gave us, I've written literally everything down.
There you go.
Like the rows and stuff, with like the S. The
What do you not understand, buddy?
I don't understand. I just 1, 2, 3.
It's weird.
You understand that 1 starts at 1, right? You understand 2 starts at 2? You cool with that?
You don't count from 3 to
Not 3 to 8, 3 to 12. Man, my apple's coming back. 3 to 12 are transition metals, and I'm not worried about them right now. I'm not going to talk about them today. Well, we will, but not right now. You with me?
the top numbers that are on the top. 1, 2, 3, all those.
Like,
Well, that's your group number, but I need you to know your valence electron number, which is you just got to know.
like Matt.
Group 1, Matt, more time. I got it. Thank you. Group 1 is group 1. Group 2 is group 2. I'm skipping the transition metals. 3, 4, 5, 6, 7, 8, 13, 14, 15, 16, 17, 18. 13 has 3 valence electrons. 14 has 4 valence electrons. 15 has 5 valence electrons. You with me?
The whole row.
Column.
The column. So the red numbers on the top, those columns.
Ish, but you got to get rid of the 1 if you want to let those numbers equal that.
Be 13 and 30. And 14 and 4. Just get rid of it.
I'm gonna have you remember a different number in a second. There's only gonna be 6 of them, so just pause that thought, okay? You with me? Just trust me. Chlorine's got 7. You with me? Okay, and everybody wants
You
the
just
magic
take the
number.
one away from 17, you just take the one away and it turns into 7.
If that's the way you want to remember it, yeah, but that's not really why, but yeah, okay? So chlorine's got 7 base electrons. Just take my word for it right now. You with me, Matthew? Come on, bud. So everybody wants 8. To get 8, sodium will get rid of 1 to go back to 8 to be like neon. Chlorine could get 1. So can we make a deal here?
Yeah, next one.
Yeah. Sodium is just going to take its 1 little electron and send it over to chlorine. Now that means sodium has 1 electron less than what it did have.
So it's back to 8.
How many? Don't worry about 8. Give me total number of protons for sodium.
11.
Okay, 11 protons. And if it was neutral, it would also have 11 electrons. But you just got rid of 1.
So it's 10.
Very good. Now let's look at chlorine. How many protons?
17.
Everybody with me? 17 protons. If it was neutral, it would have 17, but I just added 1. 18. All right, so now we are both, what word that we were talking about earlier? Ions and happy. Very good. We're both ions and we're both happy. Since sodium now has more protons than electrons, it is what? More protons?
Positive.
Positive. Chlorine has more electrons than protons.
Negative.
What happens when you get opposite things close together? Opposite things attract. So you end up with a chemical bond here, compound between sodium and chlorine. Salt, NaCl.
Never put it in your eyes.
All right. Let's check out a little bit different. Let's look at magnesium and
Magnesium
bromine.
Mg, right?
Yep.
Okay.
How many valence electrons for magnesium?
2.
Everybody with me? 2. 1, 2. Bromine, same as fluorine, same group, 7. 1, 2, 3, 4, 5, 6, 7.
One of them's not going to be happy.
Very good. So magnesium can give an electron to bromine and make bromine happy. But magnesium still has 1, and magnesium's still not happy. How can we fix that? No, you can't get rid of anything ever in chemistry. In science, you can't get rid of anything. You got to have somewhere for it to go.
Can you add it by adding another element?
Very good. What other element have I just shown you that can, well, but that makes it too complicated. We could just find another bromine. And just give that guy right there.
Now 3 are happy.
Everybody's happy.
Okay.
Magnesium has a plus, or we'll worry about charges in a second, but we have 1 magnesium and how many bromines? 2.
Would it be like 2B?
Not 2B. How do you write it to show that there's 2?
2 as like an exponent in that.
Not exponent.
It looks like it.
It's the bottom one.
It's kind of subscript.
Subscript.
Okay. Like H2O means that you have 2 what? Hydrogen, H's.
Okay.
Okay. MgBr2. All right. One more example, and then I'm going to show you the tricks of how to do this easier. Okay. Let's look at potassium and oxygen.
Oxygen.
Potassium has how many valence electrons?
1.
1. Oxygen has how many?
6.
1, 2, 3, 4, 5, 6. Can potassium get happy?
Neither of them can.
Well, potassium can get rid of its electron, right?
Yeah. So you go add another potassium.
Very, very good, guys. Y'all are catching on quick. And I'm going to make it so you can. So this potassium gives it an oxygen over there. So what is potassium oxide going to be?
K2O.
Very good. Okay.
Okay.
Now, when you name ionic bonds, all you do is name the element and then change the ending of your second thing to "ide." So let's look at these that we've done so far. This guy right here, Na is sodium.
Chloride.
Chlorine.
Well, Cl is chlorine, but we're going to change Ine to IDE.
Okay.
So instead of sodium chlorine, it'll be sodium chloride. All right. Next one, MgBr2. Magnesium is Mg. That's easy.
What else is it?
It's element. Instead of bromine,
Bromine.
bromide.
That's such a weird name.
Magnesium bromide.
K2O.
Potassium oxide.
Very good.
That's who told us to.
Not potassium oxygen, potassium oxide. If on the test you put potassium oxygenide or something like that, you change the ending wrong, I ain't mad at you. As long as you give me
IDE.
the IDE on the end. If you change the ending wrong, I ain't gonna be mad at you. So how can I figure this out without going through all of these steps? Make your life so much easier. Instead of remembering all these valence electrons, I need you to remember something else, okay? So let's look at our valence electron chart real quick. Drawing it on the board here so everybody at home can see it. So 1, 2, 3, 4, 5, 6, 7, 8. Now, which one of those numbers up there do I not have to worry about because I'm not going to talk about today? 8, because those guys aren't going to bond because they're already happy. If you find neon in nature, it is just neon. It is not bonded to anything. Same thing for argon, krypton, xenon, helium, all those guys.
So basically, we're never going to talk about group 8.
Group 18, we're not going to talk about much for the rest of the year because it didn't make any bonds. It didn't have any reactions. They're non-reactive. Okay?
They're like the noble.
So let's talk about things we are going to talk about. What do the guys with one valence electron want to do?
They want to give their electron to somebody else.
They want to give their electron away. They become what charge?
Positive.
Positive 1. If you give an electron away, now you have more protons. How many more? 1 more. Group 2 wants to give away
2 electrons.
What's their charge going to be?
Positive 2.
Group 3 or group 13?
Positive 6.
All right, we can see a pattern, but I'm going to stop at the 14 because 4 is weird. Because what are you trying to get to?
8.
And you could either gain 4 or lose 4.
So I'm guessing what? 4 neutral?
4 is weird because 4, group 14, carbon, silicon, germanium, those guys, yeah, they'll do every once in a while you'll find one that forms an ionic bond. But most of the time, the guys in group 14 actually aren't going to make an ionic bond. It's hard to find an ionic bond with carbon or silicon or germanium. The guys at the bottom, tin and lead, they're weird, and we'll talk about them later. They kind of act like the transition metals in groups 3 through 12. So we're not even going to worry about this group in the middle.
So it's kind of like 1, 2, 5, 1, 2, 3, 5, 6.
Don't. If you need to think about that, dude, you the man. Okay? So we're going to roll here. I'm going to go over to the end. What did I tell you about group 18?
Yeah, they're fun.
I ain't worried about it. So we're going to go to group 17. 7 valence electrons. What do they want to do?
Add 1.
They want to gain electrons, so they become.
Negative 1.
This guy wants to gain
2. 3.
There's 6 numbers right there that if you know those 6 numbers, you can do ionic compounds all day long. I'm about to show you why. But these are 6 numbers right here you just got to straight up remember. Group 1 plus 1. Group 2 plus 2. Skip the middle, we go to group 13 plus 3. Skip to the end, we go to group 17, negative 2, negative 3. If you can remember those 6, okay, can you count to 3? Can you count to 3? You can do it. It's not a trick, it's just something you got to remember.
What if you can't count?
Okay, calm down. It's not a trick, it's just something you gotta remember. We start counting at group 17, why not group 18?
Because they're all like.
Because those guys are happy. We don't need those guys. So 1, 2, 3 from left to right, 1, 2, 3 from right to left. We're kicking tires and lighting fires. The reason that you need to do this is so that you don't have to go through all of these extra steps to figure out this right here. Because I'm going to show you the crisscross method. All you have to do is crisscross your charges to get amounts. All right, so let's show you some examples here. Let's check out calcium chloride. Aluminum sulfide. Rubidium phosphate. And since I'm writing up here, phosphide, sorry. Since I'm writing up here, let's go ahead and do calcium oxide. I already did calcium. Strontium oxide. All right, so all you got to do is find your ion, put the charge, crisscross your charges, and it'll tell you your amounts. The other thing you need to do is reduce to lowest terms. And y'all been doing that since about the 4th grade, so that should be easy. Okay? Calcium. What letters am I writing now? Ca. What group is it in?
2.
So in group 2, what charge?
Positive 2.
Positive 2. Excellent. Chloride. Say it loud. Somebody was saying it.
CL.
Cl. Charge.
-10.
Nine.
-2.
-1. Group 17 is where you start counting. Crisscross your charges. How many CAs we gonna have?
We're gonna have 1 more.
How many CAs we gonna have?
1.
I don't need to write ones because this is chemistry class and I ain't got time for that.
That would be, it should be CHCl2.
Rock and roll.
Okay.
Where that? Speak up. Which part?
It's confusing, but I got
That's it. And screw your pluses and minuses because when they were up here, we were talking about charges, so I need pluses and minuses. When we're down here, we're amounts. I don't need pluses and minuses. Rock and roll. It's just a trick to do it faster. All right? Yes, sir.
Where'd the -1 go?
It's 1 right there. There's a number 1 right there.
it's going though. Because like,
No, there's number 1 right there.
It's like writing X.
No. It's like writing this. How many O's is that?
1.
Did I have to write 1 to tell you there's 1?
No.
You with me? That's a very good question. That's a very good question. Okay. Everybody good? Great. Good questions, guys. All right. Aluminum?
Aluminum is.
Yeah.
Yeah.
Charge?
Well,
+1, +2,
+3.
+3. Sulfide?
Sulfide is S, right?
yeah.
Yep.
And then it's
-2.
Okay, let's stop there. Make sure everybody's with me.
I'm with
1, 2, 3, 1, 2. Okay. Crisscross will make you jump.
you.
How many aluminums?
And then there'd be 3 sulfur. Wait, sulfur.
Yep.
3 sulfur.
Aluminum
You don't have
sulfide.
to put a -2, you can just put 2.
This isn't negative. This is an amount. This is a charge, so I need negative. I need positive. These are amounts. I don't need a positive negative because it's just how many you got, not a positive or negative. Rubidium?
The RB.
RB. Charge? +1. Phosphide?
Isn't it G?
It is.
And it's -3.
Crisscross make you jump.
So the RB3.
Rubidium phosphide. Strontium? SR? Charge? +2, excellent. Oxide? We've already talked about it a bunch. What's oxide? Oxygen. Just O with what charge? -2. Now here's where we get something interesting. Crisscross, what does each thing have? It'd be SR2O2. Reduce to lowest terms. Reduce this fraction for me. Everybody with me? SR2O2 is the same as SRO. Rock and roll. All right? And going the other way is easy because you don't have to worry about the numbers. Going the other way, you just say what it is. Calcium chloride, aluminum sulfide, rubidium phosphide, strontium oxide. As long as you know what the charges are, you just name it. You roll. Feel good?
Mhm.
Let's talk about the guys in the middle real quick. The guys in the middle, because you don't know about them, it's actually easier. Because, and I'll explain to you what we're going to do. Because you don't know what the charge is, I have to tell you what the charge is. So instead of just saying sodium chloride, I'm going to say titanium 3 chloride. What do you think that 3 is? What do you think that 3 is there? The charge. Since it's a metal, it's going to be positive or negative?
It would be negative.
Where are your metals at? Left or right?
It'll be positive.
Because metals are on the left. They're trying to give you their electrons. So titanium 3 chloride would be titanium with what charge? +3. Chlorine with what charge?
Plus negative,
-1.
Crisscross and make you jump.
TI.
Okay, wait, it'll be, yeah, CI3. Now I'm getting it. What is that?
Titanium 3 chloride.
So what, would you just say titanium chloride?
Nope, you would say titanium 3 chloride.
Oh.
Because if you said titanium chloride, you would say, hey, what's the charge? I don't know what titanium chloride is. You have to include a Roman numeral to tell you the charge.
Can there be like a titanium like 4?
Absolutely. That's why they're called transition elements. What does transition mean?
Change it.
They can change. So you can, if you had titanium 4 chloride, it will be titanium with a what charge? +4. Chlorine with a what charge? Crisscross make you jump. Titanium chloride will be TiCl4. Yes, sir.
I got a question about like, the ion naming.
Okay.
Right, iron 3 sulfide.
Iron 3 sulfide. Let's do it. You looking ahead the worksheet thing?
Yeah, I'm looking at
Cool, cool. That's what I like to hear. Iron 3 sulfide. All right, what's iron? You might have to look it up. Somebody help him out who's got a periodic table. You got the periodic table.
It's Fe, so it's.
You got it. Fe.
Yeah,
Fe is like right in the middle.
Yeah, it is right in the middle. Wait, it's more to the left.
What's the charge on Fe?
Oh, it's 30.
Positive 3. There it is.
Ow.
Sulfide?
Negative 2. Wait,
Well, what is it?
Oh, it's
S with a -2 charge. Crisscross will make you jump. How many FEs are we going to have?
So it'd be Fe2, F3.
Wow. Wow. Iron 3 sulfide. Now, one last thing, and this is the only thing where it gets a little itsy bit difficult. Everything to me up to here is can you count to 3? This last step is where it gets a little bit difficult. So let's look and see how to name this guy right here.
Hold on. What?
Because you need to go both ways. You need to go both ways. You have to be able to name it. If I give it to you, you have to be able to give me the formula if I name it. So first off, you got to figure out what V is. I see you looking back there. Can you holler it for me?
Don't know how to say it, but I know.
Now here's what's cool. Hey, look. I'm not trying to be mean. You speak Spanish?
Yeah.
Okay. Reading things off the periodic table is just like reading Spanish because all the sounds are always the same. But you say it exactly like it looks. You know what I mean? So it's vanadium. You with me? Okay.
Vanadium
So-
hydroxide?
Vanadium. Now here's the deal though. I gotta stop.
Is it nitride?
I gotta stop. You gotta have a Roman numeral because vanadium is where?
In it's transition.
It's a transition metal. It's in the fifth one, which is between 3 and 12.
So it'll be.
So I have to have a Roman numeral. Let's fill that in later. Let's come back and get that. What did you say the end was going to be?
Nitrate.
Not 8.
No, nitride.
You always end in those 3 letters.
I.
Nitride.
It just didn't sound right. That's the nitrate.
Nitrate is something different. We'll talk about that tomorrow. Actually, maybe Friday. Okay. So vanadium nitride. Now we got to figure out what the Roman numeral is. And you always start. Yes, sir.
Would be 2.
We'll get there. I'm going to show you. No, I'm not saying you're wrong. I'm just saying I want to take the steps. Always start with what you know. Do I know vanadium or do I know nitride?
Vanadium.
I know nitride is always going to be what charge?
It's always gonna be negative.
Negative
3.
3. Now here I look at this and I say, did my 3 crisscross and give me 3?
No, is it neutral?
What is that right there?
Oh, yeah, it did. because
Did my 3 crisscross and give me 3?
Yeah.
Yes. So what number crisscrossed and gave me 2?
Negative 2.
Positive 2.
Okay.
What number? How do I write a Roman numeral 2?
The same thing you said, just put 2.
Hold on, so wait, how did it, negative 3 gives you positive 3, but positive 2 gave you positive 2?
Because positive and negative is the charge. The metal will always be positive. The non-metal will always be negative.
Okay.
These guys down here are numbers. Charges on top, numbers on the bottom.
Okay.
Okay? Let's try a couple more and then I'll let you practice the rest of the day. So let's do 4 examples where we're going back and forth. Let's try. So for 2 of them, give me the formula. For 2 of them, give me the name. Gallium selenide, Ca3P2, cobalt 4 oxide, Ni2S5.
What do we have to do?
Give me formulas, give me names. Formula is like the letters. A formula is just, a chemical formula is just a way to write a chemical compound down.
Alright, Ca3.
You gonna do? Knock out the first one together.
Yeah.
So we got gallium, which is what?
Yeah.
Ga.
Yeah.
What do I need to know about it since it's an ionic bond?
It's positive 3.
Positive 3 charge. Selenide.
Wait, selenide.
It's negative.
I want to know what it is first. Then tell me charge.
SE.
Se, and then the charge is -2, crisscross make you jump. What is gallium selenide going to be?
GaSe3.
Forgot something.
Ga2. Okay. And
Just make sure everybody's with me. Ca?
calcium.
P?
Calcium fluoride. Yeah.
P is not fluorine. It's phosphorus, but I'm not going to say phosphorus. I'm going to say phosphate. Very good.
Yeah, that sounds
If you put phosphoride on the test, I wouldn't be mad at you.
Yeah, I just like.
As long as you end in I. You're going to find out tomorrow that you got to end in I. If you don't end in I, you're giving me something different.
For number 3, you
Okay.
want us to find like what it would look like, right?
No,
For like cobalt oxide,
what the formula is, so what's cobalt?
CO.
CO. Calcium Ca.
Charge.
Charge?
That's positive 5. That's positive.
Positive 4.
Okay.
IV. Outside?
Oxygen. Oh.
Charge?
Negative 2. It'll be CO2. CO2O4.
Can I reduce that?
CO1O2.
CO2.
Yeah, CO2.
CO2? No, it's cobalt 4 oxide.
CO2 is CO2 is.
You're thinking of, which is very different than that.
That's carbon. C is carbon, right?
Yep. That's why it's important to make sure you write your big letters and your little letters right. Last one, Ni.
Wait.
What do I need?
Positive 2.
What do I need?
Oh, need the Roman numeral.
I need a Roman numeral. S.
Sulfide.
And I want to show you, you guys are doing good, but you're skipping a step, and I want to show you why you shouldn't skip that step in a second. Okay, what's the charge on sulfur?
Wait, sulfur.
-2, so that works, right? So what's my charge? All right, I'm going to show you why you guys saw that number and said, ooh, magic, 5. And that's nothing wrong with that, because 90% of the time that'll work. But there's 10% of the time it won't. So let me show you an example of that, and then we'll be done. So let's say you got, I don't know, let's do palladium. Palladium, let's say you got, let's just do palladium. Nah, I'm doing math in my head, sorry. Palladium. Yeah, that'll work. PDN2. Now you would, using what you guys were doing just a second ago, you would think this is palladium 2 nitride, right? I'm gonna show you why it's not. Okay. PD is palladium. You know palladium is a transition metal, so it needs a Roman numeral somewhere in there. N is nitrogen, which is going to change to nitride. If you put nitrogen, I wouldn't be mad at you, but don't say nitrous oxide. That's something completely different. Okay, so we got palladium and we got nitride. We got to figure out what my charge is. What's the charge on nitrogen? -3. Do we see a problem?
If PD doesn't have it doesn't have one.
Very good, which means a reduction has happened. You've gone from a 3
To 0.
to a 1. That's not a 0. If that was a 0, it wouldn't be there.
So it'd be like
A 1. So we've gone from a 3 to a 1. So what number would reduce at the same rate to a 2? Charge of palladium?
So it's B.
Yeah, BI.
So that's why you always have to be careful not to just take the number down there.
Okay.
Okay? And that's as hard as it gets. There is no question on this next test harder than that right there. That is absolutely positively as hard as it gets. That is the maximum difficulty, which means I probably won't give you one. If I do, it'll be just one. Feel good? All right, we got a bunch of practice. Any questions at home? All right, you got this practice to rock on. We're going to add some different type of bonds tomorrow. Have a great day and keep the hard work rolling.